we have a lot of time to spare to get you guys up to date with the fundamentals, and the fundamentals are paramount. Understanding the fundamentals makes the rest of the class go by so fast. So right now, I know everyone's struggling with some of like quote unquote basic. So I say basic, but what I mean is I mean foundational. I don't mean simple. I mean foundational. So it is the basis of everything that we need to do. And so I think it is significantly more important to push back the rest of our lectures a couple of days than to and to get you guys up to speed than to keep on this predetermined track that we have set. Cool? Another okay, to begin. Homework 4 is no longer due today. Homework 4, the formal deadline, is due next week. Sorry, this is 10:10. I meant 10:17. Back. Sorry, not 10:10, 10:17. It is 10:10 today. Sorry. Homework 4 is now due a week from today. So I'd recommend, so I wrote this in the announcement, I think. I would recommend attempting at least all of the problems on homework 3. It's okay if you don't get all the way through each and every one of them. Yes, you'll get points taken off, but definitely remember this is a 2-unit pass no pass class. You will pass if you attempt. Yes, we want you guys to understand all the questions we give you, but the unfortunate part of this is that you probably won't get all the nuances, but we don't need you to get all the nuances. We want you to see these things. We want you to feel comfortable starting to use them. Does that make sense for everyone? Okay. Reminder, these are the office hours. Please ask us questions. We know it's hard to ask questions that you think are stupid. We also know it's hard to ask questions when you don't have the words to ask those questions. So if you come up to any one of us and are just like, point at a problem and like start screaming, we will start guiding you through this process. No judgment, no nothing like that. That is what we are here for. Fundamentals courses in languages are really hard. Learning Spanish for the first time is difficult. Learning French for the first time is difficult. Learning Python is difficult because it is a language. You're trying to learn how to speak the computer's language, and that's really, really hard because computers are stupid and you are smart. And so you will overthink things. I've said this before and I will say it again because I firmly believe it. So what has happened so far? A lot. We're going to do some recap lectures for the first 20 minutes or so. And then we have some problems for you to work through. We will show the solutions after giving you some time to work, either by yourselves or in groups. And if we feel it is necessary, we will hold another review session next Tuesday. Cool? Great. What did I do? I see. So here's what's happened so far. Talked about the command line, which is basically for navigating your computer and interacting directly with your operating system. That's just what runs your computer. When you open a Chrome browser, you're interacting with your OS. We've talked about GitHub and Git. You guys are pushing all of your homeworks to your GitHub repos, and using Gradescope, you are submitting your GitHub repos. We've learned about data types, which are these very fundamental objects that we have to manipulate in order to code. That is what coding is at its basis. Functions we use functions to standardize procedures so you don't have to keep writing the same code, because that sucks. Writing the same code over and over again is genuinely one of the worst things in the world, especially when you start writing a lot of code. And we'll talk more about each of these categories in a little bit. Loops, it's for iterating through a set of things and doing the same procedure to it over and over again. And conditionals is for being able to quote unquote automate decisions based on a specific criteria. If I am tired, I sleep. If I sit down, I sleep. If I wake up, I come to campus. If I take physics, I do math. All of these things happen because of these conditions. And that's what conditionals are for. So let's get into it. Command line. We started with this. So there are a few things to break down. We are capable of coding on the command line in Bash and or PowerShell. These are called shell languages. They're different than Python. When you open up your terminal, that is the language that your terminal automatically expects. We can code in Python on our terminal when we have Python installed on our computers. We can tell the computer, hey, I want to code in Python now. Please understand that I am coding in Python. And then it knows that you are coding in Python. We can distinguish between these different languages, or the computers can distinguish between these two languages by how they're built. You kind of don't need to know that, but on the back end, and the back end is basically the structure of these languages, they are fundamentally different. They interact with the computer in different ways, but you don't have to think about that. What you have to think about is syntax. And I know syntax is a word we've been using a lot. We kind of haven't really defined, and if we have, we've only defined it a couple of times. And so we do know sometimes you don't remember a thing that's only been said once or twice. So I'm going to say it again. Syntax is the components that make up a language, specifically a coding language in our, the syntax we care about is the components that make up this coding language, how to actually physically write code so that it doesn't give us an error, so that the computer knows what you're talking about. So to speak English, for you to understand me speaking English, there's certain syntax you have to follow. To make a correct sentence, you need like a noun and a verb. Most of us can understand what we're saying if we say like random words, because we have these built-in rules called slang. Python has built-in rules, not called slang. But syntax basically is how Python knows what you're saying. So in English, syntax is English words. It's these structures called sentences. It's the order of the words that make sense to our brains. The computer needs syntax to make sense of things as well. So continuing on, from the command line, we can also navigate our computer. So that was what we did in homework 2. In homework 1 and homework 2. You had to move around, you had to make things, you had to do things in your command line. And then you can write scripts. The reason it says one of many options is because there are many ways you can write scripts, as you guys all know now. VS Code is a great way to write scripts. I just prefer terminal because I'm a pick-me. That's basically it. But we want you to know your options, because knowing your options means that you can decide what the best tool is. Cool. And then you can also work with your OS. This is out of scope of the class. We will not be asking you to mess with your laptop's basic composition because that's scary. Don't do that unless you kind of know what you're doing. Which you can learn by messing up if you want. You can destroy a couple of computer operating systems if you really want to do that. That's fine. Maybe don't though. Why do we care about command line? It's cool. It's dope. It gives you a clear sense of how your computer works and how your computer is organized. Because it's this very, it's not readable, but it is blunt. It tells you everything that you are looking at, and it helps you navigate. So as we move on, you kind of don't need to think about command line because except to push your homeworks to GitHub. But if you don't want to deal with command line at all, you don't have to after homework 2. You can commit to your GitHub through the website. The website's user interface is super readable and super, it's much easier to navigate than your command line. So moving on, GitHub and Git. What is the difference between GitHub and Git? GitHub is a place to store the code. Git is a bridge between your computer and this GitHub. Git, we can use both of these to use other people's code. We cite people when we use their code, and we don't blindly use random code lying on the internet. We check it first. And then we all turn in homeworks via GitHub. There's a few ways to do it. Like I mentioned, you can do it in the command line. You have to make sure your stuff is in the directory that is linked to a repository in GitHub, which you do by cloning the repo. So git clone and then the SSH URL. All of this syntax as well is on the B courses page that, it's on the B courses page for practical applications for command line and scripting. Cool. Let me show 2 different ways of committing to GitHub really quick. Hide floating meeting controls. So let me show you guys the way that I've shown you before. So this is my command line. Rats is the GitHub repo that we created in the 3rd lecture. So one way you can tell if this is actually a GitHub repo is by typing git status. And if it doesn't give you an error, then, or if it says on branch main, your branch is up to date, or it says some other progress report, basically, then you know it's actually a Git repo. So let's make a new file. Nano is just another text editor like VS Code. It's less intuitive. So don't feel the need to new file 1.py. Don't feel the need to follow along with this. We're going to say print I love rats. And then XY enter. And then if we run Python 3 new file 1.py, it'll print out I love rats because we told it that it's supposed to be reading in Python. Now, if we type git status, it's telling us that there's a new file that is not in GitHub. And so if we do git add dot, git commit -m, and then a succinct and clear message, I'm going to say I love rats again. It'll give you this progress report, and it'll say, and then if you say git push, it'll say resolving deltas, blah, 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 blah. So that's one way. That is the way that we've shown you how to do this. Instead, let's go to GitHub. Oh shit. GitHub. Okay. This website holds all of my repositories. And if I go to rats and I go to add file and upload files, choose your files, I can add basically anything. So let's add this big telescope picture of me in front of a telescope. So I've added big telescope to this repo. I can commit the changes like this. Charlie in front of a telescope. And then commit changes. And now bigtelescope.jpg shows up in my repo. And now if I go to submit my GitHub repo through Gradescope, it will work just as well as committing through the command line. And I am happy to have you guys do this. I'd love it if you could do it through the command line, but it's not necessary after homework 2. Okay, let's keep going. Actually, questions so far? Yeah. It's already posted on vCourses. Mm-hmm. Instead of your file name, you said git commit. So git commit -m. That -m tells Git that you are giving it a message to describe your commit. And so I don't necessarily need to say, I can say that git commit -m, I uploaded a file called newfile1.py, which is fine, but not entirely necessary. And it kind of is up to you. It's up to your discretion for what is useful for you. And you will start to be able to intuit the best messages for yourself. Okay? Yeah.
Just one more thing about like submitting homework.
Uh-huh.
Like if you click submit in Gradescope and you submit a repo, it submits like
The whole repo. We know.
Is there a way to like select what is the repo or? Oh.
There is not. If you guys want to make a new repo, you can. Can you actually make a new branch? No, branches. I can't deal with it. Branches. I'm just saying that's the only way. So yes, there is. And it's painful and it sucks. So don't worry about it. It's fine. We can deal with it. So now we transition into VS Code out of the command line, thank God. So we started talking about data types. These are the objects that we manipulate with Python. All languages have data. They have ways of storing data and interacting with data. X equals 7. Y equals a string. So the most basic ones, and again, by basic, I mean the basis of all of these things, and not simple, because these aren't simple, are integers, strings, floats, booleans, lists, arrays, and dictionaries. Integers are positive and negative whole numbers. Those are intuitively named because in math, an integer is like whole numbers with 0 as well, and then the negative of the whole numbers. So if you know math, then that is a nice way to think about integers. Strings are words. Basically anything you don't want Python to like see as like something it can manipulate. Well, you can manipulate strings, but not in the way that you can manipulate integers and floats. Then anything in quotation marks is read as a string. Floats are just decimals. Another, so the name is not intuitive, but this is a thing that will just need to be memorized. Booleans are true or false. So when we talk about conditionals, we're using Booleans. True can also be interpreted as 1. False can be interpreted as 0. That is just something that happens in Python. That's just a rule about Python. Lists are objects for storing multiple of the above, including itself. A list can have lists in it, as you guys have seen in homework 3. And so that's the syntax. With square brackets, anything with square brackets, Python recognizes as a list. Arrays are objects for storing multiple of the above. The syntax is to be announced. We start learning about arrays next week. And then dictionaries are objects for categorizing sets of data. So the syntax is like key 1, value 1, key 2 to value 2. So basically we're saying, hey, within this dictionary, this value corresponds to this key. Talk a little bit more about that in a second. Yeah. That's a tuple. Don't worry about an array. Tuples, yeah, sorry, I did forget to add tuples in here. But they're not something that you really need to manipulate in this class. But yes, so tuples are like kind of like lists, but you can't change the elements, but you can change the elements in a list. Functions. Functions are really nice for standardizing a procedure that you need to replicate. So if I need to multiply 2 by 4 many, many times, and I don't want to keep writing 2 times 4, this is a bad example because writing out 2 times 4 is significantly easier than writing out function name. But the premise stands. If I want to do a thing over and over again and keep being able to call it throughout my script, it's much more useful to have it defined as some function. They work a little bit like math functions. So f of x is equal to y. If you are not familiar with that, just means that we take a dependent variable x and turn it into something else called y by multiplying or dividing or something like that. So functions take one input, or sorry, not one. Functions can take inputs. They can take more than one input. They do something to those inputs. The input can be anything. It can be a function. It can be another function. So that was a, we did that in our last discussion section with dictionaries, the lists, debugging, and dictionaries discussion section. And I know that was a little bit confusing, but you can take a function as an argument. You can take any of these data types as an argument. You can do something to the input and then output what you want to keep, because everything inside of a function is local. Once you run that function, none of the variables you defined inside of that function stick around. It's a waste of memory for Python to hold those. And this gets into memory optimization, which we don't need to care about. Loops and conditionals. Loops allow you to iterate through a predetermined set of objects. Lists are really great examples. And they do the exact same thing to them. If you don't want to do the same thing to each element, then you can add conditionals in there. So we say for an element in a list, you can say if condition 1, so let's say for time of day in Charlie's day, 6 a.m. If the time is 6:30, Charlie wakes up. Maybe. We'll see. It's a battle. It's a fight. Else elif, it is 8 a.m. Charlie is on campus in their lab. On Thursdays, elif, the day of the week is Tuesday or Thursday, and the time is 2 p.m., Charlie is in Campbell 131 because it's the Python decal. So we're here. Else, Charlie is sitting in a vegetative state and trying not to cry. Does let me relate to the kiddos. Anyways, any questions about that metaphor and how it translates into code? Okay. So for lists, we have sets of values that Python recognizes as belonging together because you put them between two brackets with commas separating them. Each element of a list can be a different data type. You can reassign each index to be, yes, no, I have mine. You can reassign each element to be something else, which is really nice. And they can be useful for loops because we tend to loop through elements in a list. You can also loop through elements in an array, but that is to be announced. And for dictionaries, dictionaries allow us to categorize sets of data with a key. Most often, we define dictionaries so that the keys are lists of data, which allows us to be organized with what we're working with. If I wanted to tell someone how numbers are defined, how numbers are categorized in math, and they said, okay, what are some examples of natural numbers? I could go to this dictionary and call dictionary natural numbers, and I would get 1, 2, 3, 4, 5. Those are all natural numbers. And note that down at the irrational numbers, we have strings and numbers in there. And that is perfectly okay. What happens if I print dictionary.keys here? What will I get back? Perfect. I cannot remember. I can't tell who said that. But good job. And then if I print dictionary.values, what will I get? All the lists. Exactly. So those are our recap lectures. Any questions? Yeah. It is all of the values that correspond, or sorry, the list of the things highlighted in yellow. So those are our keys. So if we call dictionary.keys, it'll give us a list of all of those strings, of all of those keys, which sounds like circular reasoning a little bit. People named things in Python actually very sensibly to some extent, and so it can be hard to describe. Is that all right? I know a lot of the big issues come in when we're trying to put it all together. So what we're going to do now is navigate to B courses. Come on. Exit full screen. Going to go to B courses, files, that's Intro to Python, good. Here, and then review. There's a new folder called review. These slides are in the review folder. Then the Python decal review session PDF is here. We have 18 minutes left in class. Sorry, we have 18 minutes left in class. Please, I will set a timer for 10 minutes. Work together to start parsing out this first problem. the instructors will walk around answering specific questions. But only specific questions. If you ask us something like point at the screen and scream, we will not answer that question because we want you guys to develop specific questions for this one. That is the whole point of this specific exercise. But if you point at a homework question and scream in office hours, we'll help you walk through it. Cool? Because at the end, we'll go through this all together. Okay? Do you guys want music while you work? Nice. Okay, let's do it. Go forth. We'll wait for 5 minutes or 3-ish minutes and then start walking around. Or if someone raises their hand and makes eye contact and looks very sad, if you give us puppy eyes, we'll we'll come over. We'll come over sooner. Okay, for folks who are watching this recording, please go and attempt those. You can pause the recording, and we will go through it in a second. So please feel free to stop the recording right now. So we're going to resume the recording. Going to open up VS Code. We're going to share this. I'm going to share this code. And so I'm going to hide floating meeting controls. What? Sorry. Oh yeah. No, the ballet has okay, I'm gonna go to decal 24. Save. Open that. Yes, I trust. Let's allow. Okay, make a file. We're gonna call it review. Thank you. Wait, hold on. Shit. Rename review dot hi. Okay, so let's kind of break down what I'm actually asking, because that is not a that is no mean feat. So what am I actually asking from you guys? So I'm asking you to define a list. And I'm just going to use the list I defined from before. So L's is equal to this here. And then this should be closed. This is my list. This is my other list. Okay. So here's my list. Cool? So we're going to save this. We're going to run it. Nothing happens. Good. And if I call else, then it should, I need to save it. If I say print else, save, and then run it, it gives me my list. Great. So let's define a dictionary. Is equal to, this is the syntax for a dictionary. Basically what I want to do is I want to write a dictionary where each key is an element of this list. And the value is the list raised to the 0th power, and then to the 1st power, and then to the 2nd power, and then to the 3rd power. And then I need to have a comma here. And then we're going to do it with all the other things. So I'm just gonna skip over, I'm actually gonna make this list shorter. Be- Oh, really? Oh, no, you should be writing a conditional. I'm just writing out what it is manually. Yes. And so then, damn. Hello is hello. And then 6. And then, so this is the dictionary that I want to be making. So this is the answer for what we want. This is kind of basically what we care about doing. And then it should return this. There is a way, as I'm sure some of you have come up with, to automate this. We are now out of time. So on Tuesday, we will be running through how to automate this problem, and then we'll be working on and then showing the solutions for the second problem in this file. Okay? Feel free to work on this, but prioritize your homeworks. Okay? Thank you, everyone. Go home or do whatever you need to do.